Who doesn't love cheese? You can add it to any dish, and it gets instantly better. But while we can all agree that cheese is awesome, even the biggest cheese lovers still don't know about how it's made. So, in today's video, let's put together a spread of your favorites and see what goes on inside factories. All cheese begins with one key ingredient: milk. But not all milk is the same. Most cheeses you know, like cheddar, Swiss, and Gouda, are made from cow's milk. No surprise, since it has the perfect balance of fat and protein. Sheep's milk is good too. Even though it's too rich in lactose to drink, it forms the base for Roquefort and Manchego cheeses. For a tangy twist, goat's milk produces sharp chèvre and creamy boucheron. But here's what people don't know. Turning milk into cheese requires more than just the milk itself. It needs a coagulant to form curds. Rennet comes in. While it's an enzyme found in young mammals naturally, it's now mostly made through microbial bioprocessing. But milk and rennet are just the start. Flavors come in from added salt, spices, and even wine. Making cheese requires science, skill, and a bit of patience. The people behind it are known as fromagers, or cheesemakers. And despite how much variety there is, the early steps in the process are surprisingly similar across the board. Since milk is the foundation of every cheese, it's important to start with the perfect batch. But what does perfect mean? That honestly depends on the type of cheese you want to make. Cheesemakers start by adjusting the milk to ensure the right balance of protein and fat. The milk is then usually pasteurized or treated with mild heat. This not only kills off unwanted organisms that could spoil the cheese, but also gets the milk in the right condition for the starter cultures to thrive. Once the milk is pasteurized, it's cooled to around 90 degrees Fahrenheit. Next comes a critical step in the cheese-making process: acidification. Left on its own, milk will eventually turn sour due to bacterial growth. But this natural process is unpredictable, and the end flavor isn't always pleasant. To control this, cheesemakers add starter cultures to the milk. These cultures are carefully selected strains of bacteria that help acidify the milk in a predictable way. At this stage, the milk should already be at 90 degrees Fahrenheit, and it stays at this temperature for about 30 minutes while it ripens. During this time, the pH level of the milk drops. The basic flavor profile of the cheese is already forming. Our product is still a liquid, so it's time to give it some texture. This step, called curdling, is where milk starts its transformation, and rennet is used here. The science behind it can get complex, but this reaction basically causes the milk to thicken and form solid lumps called curds. Plus, it leaves behind a liquid byproduct known as whey. Once the curd has formed, it's time to separate it from the whey. The curds and whey mixture is allowed to ferment and settle until the pH level drops to about 6.4. By this point, the curd has coalesced into a solid mass within the cheese-making vat. Now comes the cutting. Using long curd knives that reach all the way to the bottom of the vat, cheesemakers slice through the curd in a crisscross pattern. This step is crucial because cutting the curd increases its surface area, which allows for more separation from the whey. The size of the curds after cutting is a key factor in determining the final texture of the cheese. Larger chunks of curd tend to hold on to more moisture, resulting in a softer, moister cheese. But smaller curd pieces will lose more moisture. This will end up in a firmer, drier cheese. Once the curd has been cut, the next step is processing it more. This involves cooking and stirring the curds, or sometimes both. The goal here remains the same: to encourage the curds to continue releasing moisture, separating them even more from the whey. The more the curds are cooked and stirred, the drier the final cheese will be. Another technique used at this stage is washing the curd, which involves replacing the whey with water. This step impacts the cheese's flavor and texture, typically resulting in a more elastic cheese with a mild, pleasant taste. Washed curd cheeses like Gouda, Havarti, and Swedish Fontina are known for their smooth texture and subtle flavors. By now, the curds and whey have separated a lot, so it's time to remove the whey entirely. Draining the whey leaves behind only the solid curds. They can range in size depending on how finely they were cut. With the whey removed, the curds will start to resemble a thick mat. There are different methods to drain the whey. In some cases, cheesemakers let the whey drain off naturally, especially for softer cheeses. But when making harder cheeses that require less moisture, they often use a mold or press to compact the curds and squeeze out even more whey. For certain types of cheeses, there's an extra step to extract even more moisture, a process known as cheddaring. In this step, the curd mat is cut into sections. These sections are stacked on top of each other, and the weight from stacking presses out more whey. As the process goes on, the cheesemaker keeps cutting the slabs and restacking them, squeezing out even more whey each time. The longer this process lasts, the denser and crumblier the cheese becomes. Once the curd reaches the desired texture and acidity, the slabs are milled into smaller pieces. Now that the curd is taking on its final shape, it's time to enhance the flavor. Cheesemakers salt the cheese at this stage, and there's different ways to do it. For example, mozzarella often gets a brine bath, but drier cheeses are typically dry salted. Some cheeses are even flavored with spices and herbs. The possibilities for flavoring cheese are endless. This isn't as common though. Usually the goal is to let the natural flavors shine, with just salt bringing out that cheesy flavor. There aren't any more ingredients to add to the cheese at this point, so it's ready to be shaped. Even with so much moisture removed from the curd, it's still malleable and soft. So cheesemakers are able to press the curd into molds to create standardized shapes. Molds can be in basket or hoop form. Baskets are molds that are only open on one end, and hoops are bottomless molds, so they only wrap around the sides of the curd. In either case, the milled curd mixture is pressed into the mold and left there to solidify into the right shape. For many cheeses, the journey isn't over until they've aged. This process, also known as ripening, is what gives its final flavor, texture, and character. Cheese is aged in cool, humid conditions, allowing natural changes to harden the cheese and intensify its flavor. This can take anywhere from a few days to several years, and there are two main types of aging. Interior ripened cheeses are sealed with a rind, causing them to age from the inside out. Think cheddar or Swiss. Then there are surface ripened cheeses. These age from the outside in, developing a natural rind. Brie and Munster are good examples. Once aging is complete, the cheese is ready to be enjoyed. Well, there you have it. Whether it's in a mozzarella stick or the finest Swiss cheese, it all starts the same. To find out more about how your favorite foods are made, subscribe and check out the other videos on our channel. Until then, thanks for watching.
More than 6 billion people in the world consume milk and milk products. That's roughly 75% of the world's population. In just the US, a whopping 100 billion liters of milk is produced each year. But have you ever looked at the glass of milk on your breakfast table and wondered what goes on behind the scenes? The process begins on dairy farms, where cows are raised specifically for milk production. These cows are kept in clean and well-maintained environments, and the farmers take a lot of care in making sure that their cows remain stress-free, since that ultimately affects their milk production. Dairy cows are usually milked 2 or 3 times a day using milking machines. The average cow can produce anywhere from 25 to 35 liters of milk every day. Milking machines are designed to be gentle and efficient, ensuring the well-being of the cows. In modern farms, several milking machines are attached to a rotary parlor, which can accommodate anywhere from 20 to 80 cows at the same time. The raw milk flows through stainless steel or glass pipes to a refrigerated bulk milk tank where it is cooled to about 4 degrees centigrade. After the cows have been milked, a refrigerated bulk tank truck makes collections from dairy farms and delivers them to the processing facilities. Before pumping the milk from each farm's tank, the driver collects a sample and checks the flavor and temperature and records the volume. Because milk is a perishable commodity, dairy farms and processing facilities are usually in close distance to one another. At the milk processing plant, the milk in the truck is weighed and pumped into refrigerated tanks in the plant through flexible stainless steel or plastic hoses. the cold raw milk passes through either a clarifier or a separator, which spins the milk through a series of conical discs inside an enclosure. A clarifier removes debris, some bacteria, and any sediment that may be present in the raw milk. A separator performs the same task, but also separates the heavier milk fat from the lighter milk to produce both cream and skim milk. Some processing plants use a standardizer clarifier, which regulates the amount of milk fat content in the milk by removing only the excess fat. The excess milk fat is drawn off and processed into cream or butter. Next up, the milk is fortified, which involves the addition of specific minerals and vitamins to enhance its nutritional content. This process is typically done to address nutrient deficiencies or to meet specific dietary requirements. Usually, vitamins A and D are added to the milk with the help of a peristaltic pump, which automatically dispenses the correct amount of vitamin concentrate into the flow of milk. The milk, either whole milk, skim milk, or standardized milk, is piped into a pasteurizer to kill any bacteria. The process was discovered by Louis Pasteur of France, who actually developed it to kill the bacteria in wine to prevent it from turning into vinegar. Later, it was found that the process could be used to kill harmful bacteria in not just wine, but a variety of food products. There are several methods used to pasteurize milk. The most common is called the high-temperature, short-time HTST process, in which the milk is heated as it flows through the pasteurizer continuously. Whole milk, skim milk, and standardized milk must be heated to 72 degrees Celsius for 15 seconds. Other milk products have different time and temperature requirements. The hot milk passes through a long pipe whose length and diameter are sized, so that it takes the liquid exactly 15 seconds to pass from one end to the other. A temperature sensor at the end of the pipe diverts the milk back to the inlet for reprocessing if the temperature has fallen below the required standard. In raw milk, the fat content is naturally present in the form of globules. Over time, these fat globules can rise to the surface, causing cream separation, so milk is homogenized to reduce the size of the remaining milk fat particles. This prevents the milk fat from separating and floating to the surface as cream. It also ensures that the milk fat will be evenly distributed through the milk. The hot milk from the pasteurizer is pressurized to 2,500 to 3,000 psi, 17,200 to 20,700 kPa by a multiple-cylinder piston pump and is forced through very small passages in an adjustable valve. The shearing effect of being forced through the tiny openings breaks down the fat particles into the proper size. The milk is then quickly cooled to 4 degrees Celsius to avoid harming its taste. In the production of powdered milk, there's one extra step involved before the packaging process. First, the milk is concentrated to increase its solid contents. This is typically achieved by evaporating a significant percentage of the water, leaving behind a more concentrated liquid. After concentration, the milk concentrate is then subjected to spray drying, which is the process that transforms the concentrated liquid into powdered milk. The concentrated milk is first fed into a chamber where it is atomized, meaning it is broken down into small droplets. This is typically achieved by spraying the liquid through a nozzle. The droplets are then introduced into a drying chamber. Hot air is simultaneously blown into the chamber, causing the water content in the droplets to evaporate rapidly. As the water evaporates, the remaining milk solids form tiny dry particles. These particles fall to the bottom of the chamber, and the dried powder is collected. The processed milk is then packaged into various containers, such as cartons, bottles, or jars in the case of powdered milk. One of the first glass milk bottles was patented in 1884 by Dr. Henry Thatcher, who came up with the idea after seeing a milkman making deliveries from an open bucket, into which a child's filthy rag doll had accidentally fallen. By 1889, Thatcher's common sense milk jar had become an industry standard. Packaging is done under strict hygiene standards to prevent contamination. Throughout the production process, rigorous quality control measures are implemented. This includes testing for bacterial contamination, checking for proper pasteurization, and ensuring the milk meets regulatory standards for various components. This is important because the milk must comply with these standards to be classified as Grade A milk, which is about 90% of the milk produced in the United States. If the milk somehow doesn't fall on these stringent standards and receives a Grade B, it can only be used in the production of certain cheeses, which undergo further processing. The gold standard in sanitary conditions is certified milk, which is sold at a higher price than Grade A milk. To ensure sanitary conditions, the inner surfaces of the process equipment and piping system are cleaned once a day. Almost all the equipment and piping used in the processing plant and on the farm are made from stainless steel. Highly automated clean-in-place systems are incorporated into this equipment that allows solvents to be run through the system and then flushed clean. This is done at a time between normal influx of milk from the farms. Once packaged, the milk is distributed to retailers through a cold chain to maintain its freshness. Refrigerated trucks are commonly used to transport milk to ensure it remains at the appropriate temperature. The milk reaches retail outlets where customers can purchase it for consumption. Commercially produced milk is available in various forms, including whole milk, skim milk, 2% milk, and specialty products like flavored milk or lactose-free milk. That was all about how milk is produced, from its humble beginnings in a dairy farm to the aisles of grocery stores. If you want to know about how ice cream is made, check out this video.